In this video, I'm going to be making the ASCARVA 4S even more powerful by replacing the stock 70-watt spindle motor with this huge 500-watt spindle motor. Hi everyone, welcome to the Laser Channel where we learn, create, and share. My name is Greg, and before we get started and we check out the kit that this 500-watt spindle motor is a part of, I do want to let you know that I do have this video indicated as paid promotion. I'm not actually being paid by ACMR to produce this video, but they did send me the kit that this motor is a part of, and I just want to be fully transparent with you. I'm under no obligation to say or do anything specific in this video, other than to use the product and share my experience with all of you. I never do a paid promotion video with a hidden message in it. That's just not how this channel operates. Now, with that covered, we're going to move on to more serious business, such as the first question that I actually have for all of you, and that is, what side of a turkey has the most feathers? Don't know? It's the outside, of course. All right, now with all of that taken care of, let's check out the kit that this motor is a part of. The kit arrives in this exciting brown box. It actually has quite a bit of weight to it, meaning that there's going to be definitely a lot more than just the spindle motor inside. So without any further riddle deficient babbling, let's get on to the inside. We're first greeted by the installation manual, shows all the parts included, and then goes through step by step all the instructions for installing the kit on the machine. Got some nice black squishy foam, and let's check out the motor once again. This thing has some serious weight to it and a nice industrial connector on it to handle all the power that we'll be sending out to it. The clamp for the motor is going to be made from a solid piece of aluminum. It is anodized the same orange color as the machine, and this is also going to act as a heat sink for this powerful 500-watt motor. I've got a bag of screws and some zip ties to tighten everything up. The screws, of course, are going to be for the motor clamp. Underneath that is going to be a power cable from the power supply up to the machine itself. The stock power supply that comes with the machine will no longer be used. Here I've got a couple of cables. I'll get the twist tie off, and the first one is going to be this smaller cable. This is simply going to be the signal cable to tell the power supply to turn the motor on and off. That comes from the main unit here. We'll check that out in just a couple of minutes. The last cable is this heavy-duty cable with these industrial connectors. This is going to handle all of the voltage and power from the power supply out to the motor. The excitement continues by finishing off with a huge power supply. On one side, we've got the power in and out, and on the back side is the input voltage from the wall outlet, along with a large red button for power on and off. It's nice to see that ACMR finished the color scheme in black and orange to match the machine, making this a seamless integration kit. Hang on a second, I almost skipped a couple cool things on the spindle motor, starting out with the installed EC11 collet. This is going to accept 1/8 inch tooling, and the motor itself is going to be rated for 48 volts, which means the power supply is going to have an output of that same 48 volts for just the spindle motor, and a separate built-in supply for 24 volts to power up the rest of the ASCARVA 4S. So maybe you're asking yourself, why would we want to upgrade the spindle motor on our desktop CNC machine? And the easy answer is, well, it's more power, but when I dig into that, this motor is going to be spinning quite a bit faster. The stock motor is rated at, I think, about 8,000 RPM, and the total wattage is 70 watts, which is fairly low for an application like this. But this being an entry-level beginner desktop CNC machine, it does have to hit some certain price points, and putting a smaller spindle motor is certainly one of the cost savings area. This larger motor is going to be spinning at upwards of 12,000 RPM, and of course it's a lot more powerful, meaning that I can speed up my machine when I'm making projects, so it's going to save a lot of time. Let's check out the stock wiring of the machine before I install the spindle kit. On the front of the machine, I've got power running in with the stock power supply. From the main control box, all of the wiring comes out through this nice, neat energy chain. It goes through a little breakout point with all the wires and connectors nicely labeled. There's another energy chain behind the machine that goes through up to the controls and also the spindle motor. Now it's time to get the new spindle motor installed. The kit's installed and everything went smoothly. I took my time, enjoyed the process. Speaking of time, it took me less than 20 minutes to install. It should take you probably even less than that, maybe about 10 to 15 minutes. It takes me a little bit longer because I'm moving the camera around, I'm playing with studio lighting, and things like the phone was ringing in the background. Lots of different distractions. Overall though, a very fun kit to install. Let's turn this motor on and see what it looks like. Everything looks good. I have a green indicator light on the new power supply. We check out the display. Hopefully it shows up on camera. That came up properly. Let's turn this light on and turn the spindle on for the very first time. I'll navigate through the menu system. We'll get the working light turned on. That looks good, and fingers crossed, let's turn the spindle on. Holy cow! Maybe I should have had the collar on tight. I should probably turn that off right away. The kit's all installed and everything tested out perfectly, and next up I'm going to do something that might actually shock some of you. I'm going to stop talking. I thought, what better way to check out the kit than to actually run a bunch of projects? So off camera, I cut a bunch of different project material out of this 1/2-inch MDF material. This is great stuff for beginners just like me. I'll keep the camera rolling so that we can see some video clips and maybe some time lapses of some projects being made with this new spindle kit. In just a second, we're going to be checking out the projects and my experience that I had running the updated Spindle kit and the software creating these 3 projects. Now before that, I think I've got some even more important information, and it's related to the Spindle motor kit. Now, first of all, I believe I'm one of the first people in North America to get early access to this kit. Part of that is sometimes I'm going to run into things that you, the general public, will not experience once the kit is hopefully refined just a little bit more. The biggest thing that I saw is when I first turned the spindle motor on, it was spinning in the wrong direction. I looked over the power supply box. There's no flip the switch. I checked the wiring over. All the wire connections are keyed, so they only connect one way. I can't mess that up. I checked out the software. There's not really anything in the software that I can click a button or something and make the spindle turn the opposite direction. This machine simply doesn't have that feature. It's just more of a, you turn the motor on or off and it spins the direction that it should, or in this case, the opposite direction. Obviously, I made 2 projects, or actually 3 of them. So how did I overcome that? I made myself a little jumper that crisscrossed the wires. I do a lot of playing around with RC cars, and these yellow connectors are very common. So as luck would have it, I had a bag of these and I was able to make one of these crisscross jumpers. The vast majority of router bits for our machines are meant to spin in the clockwise direction. There are going to be a very select few router bits that are meant for the spindle to turn in the opposite direction. I think it'd be great if Acmer updated the power supply box to have a switch on it to run the spindle in forward or reverse without the need of having one of these little jumpers. The other big thing that I noticed from switching out from the stock 70 watt motor up to this 500 watt one is that there's a lot less tool deflection when making projects. With the stock motor, I could grab onto the collet and I could kind of wiggle the motor around. There's a lot of sloppiness within the collar that tightened down on the motor. And then in this whole assembly here, and even this 500 watt will do it too. I can kind of wiggle it back and forth, and that destroys accuracy. While the 500 watt still has a little bit of that wiggle, it is a lot better, but it is still there. And I think that's just going to be one of the things that we're going to find on one of these entry-level CNC machines. Certainly the 500 watt motor is a huge upgrade over that stock 70 watt motor. I think if you're looking at this machine, definitely buy it with this 500 watt spindle motor. You're gonna have a much better experience. Now, speaking of experiences, let's go over some of my thoughts when I was making these projects. The first project was this plywood coffee cup coaster. The plywood is about 0.4 inches thick, and the wood material itself is nothing special. This is some leftover wood from a crate that a CO2 laser machine came in, and I like to hang on to that and just use it for practice projects just like we saw in today's video. When we take another look at this, we're going to see that I think I went a little bit too deep in certain spots. I see some red color coming through from the glue that was used to make this plywood. The projects that I made in this video were smaller so that I could make my mistakes faster, and you heard that correctly. I want to make mistakes when I'm making my projects. This is the best way for me to learn and apply it to other larger projects. I don't want to make mistakes on really big projects. It wastes a lot of time. But if I can make these fun little projects and learn along the way, that's going to put me so much further ahead of learning the machine and the software. And while I was making all of these CNC projects, I think one of the other biggest learnings that I need to do is to keep a journal book, and that's actually what I've got now. I want to record my speed settings, the material that I'm using, and the router bit that I'm using, and start to develop this catalog of experience on what works and what doesn't work. The next project was this dog that I made. It was a simple SVG file that easily imported into the software. And it is made out of 1/2-inch MDF particle board. As I mentioned at the beginning of the video, this stuff is great. It machines really great with basically any tooling, and most of all, this material is dirt cheap and it can be found just about at any hardware store. And just like the first project, I learned something from this project. When I did my depth of cut on this one, I cut much deeper than I actually really needed to do. I could have had the same effect by cutting half the depth, which would have reduced the project time by half. This brings us up to the last project where I did some wavy lines. We'll see if we can get that in focus. This was, I think, was supposed to be much deeper. The machine cut to the depth that I told it to. I just thought that the lines with this V-tip bit that I had in the machine would have showed up a lot better. The other thing that we saw during the time lapse is, well, I got about 1/3 of the way through and then the machine just simply stopped. When I came back out to the shop, I saw that my computer had gone to sleep, and I think the software that I'm using to send the information out to the machine, it doesn't send it all at once. I think it is streaming it, and when the computer went to sleep, that stream stopped and the machine didn't have any more commands, so it's just simply stopped where it ran out of information from the computer. During my own research on learning how to run one of these machines, I ran into a couple bits of advice that I saw several times over, and it recommended not running the computer to stream the program up to the machine just for the reasons that we saw. If the computer goes to sleep or it shuts down or the USB cable gets disconnected, the machine will stop where it's at. Instead, they recommend exporting that program file onto the SD card and putting that in the machine and then running the program locally as a standalone program. And that was my big learning with this last project, is to probably start running the programs locally from the machine. So far, I've been having an enjoyable experience running the machine, and with the 500-watt spindle motor, the projects are being made about 4 times faster than I did over this little tiny spindle motor. So in comparison, in the past, one of these projects would have taken hours and hours to make. When I recorded all 3 of these projects, they were all done in one afternoon. I actually had a late lunch that day and didn't start recording the projects until about 1 or 1:30 in the afternoon. And they were all scheduled to be done by 5 o'clock that same afternoon, minus this one that stopped well before that because, well, the computer went to sleep. Other than the major issue of the spindle motor turning the wrong direction, the rest of the kit install went by very quickly and very easily. And with this more powerful spindle motor, I can run the machine a lot faster, and that's definitely adding to the enjoyment level of learning and creating things with a CNC router. Thanks for joining me in this video. I hope that you found it entertaining and maybe you learned something about the Acme ASCARVA 4S and the 500-watt spindle motor. If you like this video, show it some love by giving it a like or subscribing to this channel. Not only is it a great way to help the laser channel grow, it's an awesome way to connect video content like this with other great viewers just like you. And until we meet again in the next video, I'm Greg from the Laser Channel, where we learn, create, and share.